everyone, in this video we will talk about force vectors. Now to start, what is a vector? The definition of vector is any physical quantity that requires both a magnitude and a direction for its complete description. So here we have a vector A that has a magnitude OP and a direction 20 degrees counterclockwise. Now moving on. So to do vector addition, we have two vectors, vector A, vector B at first. So if we want to do the addition of A plus B, which is here, let's call it R, we bring vector B, the origin, to the same origin of vector A, we complete the parallelogram, and then the diagonal will be the resultant R, which is A plus B. Now another method to do that is represented here. So we bring the origin of vector B to the tip of A, and then we just complete the triangle and we have the resultant R. Or the same way as we can bring the origin of vector A to the tip of vector B, and then completing the triangle, we get the resultant R. Now let's say we want to do A minus B, and here let's call it R prime. So A minus B is basically the addition of vector A and the vector minus B, which is the same magnitude as vector B, just opposite direction. So all we do is flip the direction of vector B, and then we can bring both to the same origin, we complete the parallelogram, and then we have R prime. Now let's talk a bit about summing two, three or more vectors. So we just do the sum of two vectors at a time. So if we have A plus B plus C, we do A plus B, which is R, and then we do R plus C, which will give us, let's say, vector F. So here we have vector R, which we got from before, we add vector C, and we get vector F. So since we talked about this, let's do maybe a very simple example. So if we have two forces, one 150 Newton shown in this direction, another one 100 Newton at 15 degrees, and we want to know what is the resultant force of these two. So basically the sum of these two forces. So first we know the x component of Fr is 100 cosine 15, which is the x component of the 100 Newton force, plus 150 sine 10, which is the x component of the other one. And we do the same thing for the y component, so Fry is 150 cosine 10. This is this force. If we bring it over here to the y-axis, we get this, which is the y component of the force, and to get the x component we just bring it down over here and we have the y component. So it's so Fry is 150 cosine 10 plus 100 sine 15. So the magnitude of the force Fr will be the square root of Frx squared plus Fry squared. This is just the Pythagorean theorem. I'm plugging in the numbers here, which we will not go over. We will get 230 newtons. Now also we want to know the direction of this force vector. So we want to get theta, the angle from the horizontal axis. So theta is just the arctangent of Fry over Frx. This is just as if from the triangle rule, the right triangle rule. So we have y, x, and let's call that f, and this is theta. So we know that theta is arctangent of y over x, and it's also arc cosine of x over f, or arc sine of y over f. Now that we've covered this, we can talk a bit more, explain x components, y components, So let's say we have three forces over here. We want to get the resultant force of all three of them. So Fr is going to be F1 plus F2 plus F3. So one way to do it is to break down every force its x and y component. So F1 would be F1x I, which I is the unit vector for the x-axis, plus F1y j, j is the unit vector of the y-axis. So completely, this will give us this is basically F1. So we have minus F2xi. Now notice the minus is because F2 is in the negative x direction, plus F2yj plus F3xi minus F3yj minus F3yj because it's in the negative y direction. Now this is basically Frxi plus Fryj. So this came from, so Frx is basically just the sum of the forces in the x direction on the particle, and Fry is the sum of the forces in the y direction. Now the magnitude of the force Fr will be the square root of Frx squared plus Fry squared, just like we did in the example previously. And the angle theta from the horizontal axis. So here let's say this is Fr. Theta will be this angle. So theta is arctangent of the magnitude Fry over Frx. Now let's talk about Cartesian vectors. So now we are in 3D. We have the axis x, y, and z. So here we have ax, ay, and az. So the vector A is the sum of all three of them. Now notice how I got that vector, but to get the drawing of that. So basically I summed ax and ay by completing the parallelogram. I get a prime, and then I sum a prime with az, I get a. So A is the vector ax plus vector ay plus vector az, which is the magnitude ax plus ay plus az. And to get the magnitude of A, we just do the square root of ax squared plus ay squared plus az squared. Now, let's talk a little bit about position vectors. This just gives us the position where the vector is. So looking at this picture over here, we have vector Ra, vector Rb, and vector R. Now if you remember what we first talked about, if you look at it, Ra plus R will give us Rb. And basically R will be xb minus xa, because, well, R is basically Rb minus Ra, which will lead to this. So R is xb minus xai, yb minus yaj, plus zb minus zak. Now, what is the dot product? So here, let's say we have two vectors, A and B, with angle theta between them. So if you want to do the dot product of both of them, it's just basically the magnitude A times the magnitude B cosine theta. So, or another way to do it is ax times ab plus ay times by plus az times bz. Now, where can we use this system? Let's say we have these two vectors and we want to find the angle theta between them. Well, one way to do it is to do the arc cosine of the dot product ab plus a times b over the magnitude a times b. Now this kind of gives us a good grasp of the basics of force vectors, which will be used more later in future chapters. Thank you.